Let's practice solving a linear system by using substitution together. While on a previous video we focused on solving systems by using the method of graphing, and in a future one we'll do one with elimination, this particular video on these practice problems will deal with the method of substitution. We typically try to use this substitution method when it's easy to isolate one of the variables in the system of equations. For number 1, we have the equations y is equal to 3x plus 2 and x plus 2y is equal to 11. So notice right away that the y in the first equation is already isolated by itself, and the y in the first equation must be the same as the y in the second equation. Now if y is equal to this expression of 3x plus 2, they're the same thing, then we should be able to swap out the second y in the second equation with that 3x plus 2. So let me show you what I mean by that. So I'm going to go ahead and rewrite the second equation as x plus 2, but instead of writing times y, I'm going to change y to the 3x plus 2. Again, they're the same thing, right? And that's going to equal 11. Okay, at this point we have an equation that just has one variable, so it's going to be easier to solve. Let's go ahead and distribute this 2 to the 3x and to this 2 over here. So we're going to have x, and then 2 times 3x, that's going to be 6x. Then 2 times 2 is going to equal 4, and that's going to equal 11. From here, we're just going to go ahead and combine like terms. We have this 1x and 6x we can combine together to make 7x. So we're going to get 7x plus 4, and that's equal to 11. Next, we can go ahead and subtract 4 from both sides of the equation. If we subtract 4 and 4, the 4's are going to cancel out on the left side, and we're going to be left with 7x is equal to 7. Finally, one more step, we can divide both sides by 7, so that we get 1x equals, or just x equals, and that's going to equal 1. Now that we know that x is equal to 1, we can go ahead and use this information to help us figure out what y is equal to. So we can take that 1 and either substitute it in the first equation here, or we can substitute it into the second equation to solve for y. Now since the top equation already has y isolated, I'm going to go ahead and use that one. So let's go ahead and substitute that into this first equation and plug that in for x. So if we do that, we're going to have y is equal to 3 multiplied by that x. So let's go ahead and substitute that in as 1, and then plus 2. Now what is 3 times 1? 3 times 1 is 3, so we're going to have y is equal to 3 plus 2, and 3 plus 2 is equal to 5, so y would equal 5 when x is equal to 1. So this right here would be our solution for our x-coordinate and our y-coordinate. Now that we know that x is 1 and y is 5, our solution is going to be the point 1, 5. Now just to check our work here, remember this is an x value and this is a y value. Now to make sure that our answer does make sense, let's take our solution of 1, 5 and let's swap out x for the 1 and then the y for the 5 over here. Okay, so if we go ahead and do that, let's see what that's going to be. That's going to be 5 in for y. That's going to be 5 is equal to this 3 times, what is x? X is 1. Let's go ahead and substitute 1 in there, and then plus 2. Okay, so let's see if those are equal to each other. We're not sure, so let's go ahead and say that's going to be 5 on the left side is maybe equal to 3 times 1, which is 3 plus 2. 3 plus 2 is equal to 5, so since 5 does equal 5, then this does make sense because this is true. Okay, now we can plug it into the second equation as well, so take that point and plug it in over here to make sure it also works. So let's change x to 1 again and y to 5. If we go ahead and do that, let's go ahead and say it's going to be 1, and that's going to be plus 2 times y. Now y we think is 5, so let's go ahead and plug in that 5. We're wondering if that equals to 11 or not, right? So on the left side here, we would multiply 2 times 5, so that would be 10. So 1 plus 10, does that equal 11? Well, 1 plus 10 is 11, so 11 does equal 11. So we can see here that this does check out, so our solution must be true. For number 2, we have the equations x minus 2y is equal to negative 6 and 4x plus 6y is equal to 4. Now for practicing the strategy of substitution, we should be trying to see which variable we can get alone. So if we take a look at the x in the first equation, that one looks like it's going to be the easiest to get by itself. So I'm going to go ahead and copy down equation 1 here. I'm going to say x minus this 2y is equal to negative 6. Now to isolate this x, what we're going to do here is add 2y to both sides. So add 2y on the left and add 2y on the right. If we go ahead and do that, then this x will be isolated. We can say that x is equal to, let's write it as 2y minus 6. Okay, so this was the same thing as equation 1. So notice how we have this x completely isolated now. And if you look at the second equation, we do have an x here as well, right? Now, if x is equal to this 2y minus 6, then we should be able to change x in the second equation to this 2y minus 6, or substitute it. So let's go ahead and take this 2y minus 6 and substitute that in for this x in the second equation. Okay, so I'm going to go ahead and do that here. Let's say we have 4 multiplied by the quantity of this 2y minus 6. Again, that's the same thing as x. And then we're going to go ahead and add 6y to that and say that's equal to 4. Okay, again, that's the same thing as the second equation. We just made a substitution for x. Now we have an equation with just y, so we can actually solve for y, right? Only one variable now. So let's distribute this 4 to both of these terms. 4 times 2y, that's going to be 8y. Then 4 multiplied by negative 6, that's going to be negative 24. Then we have a plus of 6y, and that's going to be equal to 4. Now if we go ahead and combine some like terms on the left side of the equation, we have 8y plus a 6y. 8 plus 6, we add their coefficients, that's 14y. So we have 14y minus 24, and that's equal to 4. At this point, we just have a two-step equation, so let's go ahead and add 24 to both sides of the equation. Adding 24 to both sides here, then the minus 24 and positive 24 will cancel out, and we're going to have 14y is equal to 28. And then we can divide both sides by 14. 14 divided by 14 will become a 1, so we have 1y, or y, is going to be equal to, and then 28 divided by 14 is 2. So we now know that y is equal to 2. Now we know that y is equal to 2. Let's go ahead and substitute it into either the first equation in this location here where y is, or we can substitute it into the second equation. By doing this, we can solve for x. Now, I'm going to choose to use a second equation here, so let's go ahead and take this y is equal to 2 and just substitute it in for this y over here. Okay, so I'm going to go ahead and write that second equation. We have 4x plus 6 multiplied by 2. That's what we just found out y was equal to, and that's equal to 4. Okay, now multiplying this 6 times 2 together, that's going to be 12. So we're going to have 4x plus 12, and that's going to equal 4. Then it's a two-step equation, so let's just go ahead and subtract 12 from both sides. Subtracting 12 from both sides, we're going to see here that 4x is going to equal negative 8. And then finally, we can divide both sides by 4, and x will equal negative 2. So when y is equal to positive 2, we can see here that x is equal to negative 2. And we think that putting these two together would be the solution for this system. All right, so what we think the solution here is going to be the point negative 2 comma positive 2. But let's go ahead and check that to see if this is true or not. So again, this is an x value and this is a y value. Let's go ahead and substitute it into the first equation. So let's take x as negative 2. Let's substitute that right here, and y is positive 2. Let's go ahead and substitute that in right here to see if this does make sense. So for that first equation, we're going to take x as negative 2, and that's going to be minus 2 times y. Now we said y was positive 2, so go ahead and substitute that in, and hopefully this is equal to that negative 6 on the right side, right? We're going to hopefully see if this makes sense. This is going to be negative 2, and then this is going to be minus 4, because 2 times 2 is 4, equals negative 6. Negative 2 take away 4 is negative 6. So negative 6 does equal negative 6, so this does make sense. Okay. Now into the second equation, right? Let's go ahead and confirm this. Let's take the solution, and let's plug it in for each of the x and y values that we think they are. So we have 4 multiplied by x. We think x is negative 2. And then plus 6 times y. We think y is positive 2. Let's go ahead and change that to positive 2. And hopefully this all equals 4. All right, so let's go ahead and check that. So 4 times negative 2 is negative 8. And then 6 times 2 is positive 12. We can do this in the same step. That hopefully equals 4. Negative 8 plus 12, that does equal positive 4. So since 4 does equal 4, then our solution should make sense here. Here's number 3. For number 3, we have this system of x is equal to 17 minus 4y, and y is equal to x minus 2. So actually, for this one, I don't think it really matters. It's really your preference of which one you want to use to substitute. Notice here that x is already isolated in the first equation, so we could swap 17 minus 4y and change whatever x is down here to that 17 minus 4y. Or we see that y is also isolated in the second equation, so we could definitely just take the y that's over here in the top equation and then swap it out for this x minus 2. So it's really a preference for you. I'm going to go ahead and I think I'm going to take this y that's in the second equation and substitute it in for the y in the top equation. My thinking here is that this y is equal to this x minus 2, which isn't too complicated, and we can go ahead and just change that to this y up here. And I think that's a little bit easier than substituting in the 17 minus 4y, but it's totally up to you what you'd like to do there. So let's go ahead right away and take this is equal to y, and let's just go ahead and change out y to that entire expression. So we're going to have the first equation as x is equal to 17 minus 4 multiplied by y, but instead of writing y, we're going to write x minus 2 because they're the same thing, right? Let's go ahead. We have an equation with just x's, so we can actually solve it. So let's go ahead and distribute this 4 to both terms over here. If we do that, we're going to have x is equal to 17 minus, and it's 4 times 1x, so that's going to be 4x, and then it's this negative 4 times a negative 2, so make sure we do write a positive 8 there. Okay, again, we're distributing a negative 4. On the right side of the equation, it looks like we have some like terms that can be combined here. So we have 17 and 8. So 17 plus 8 would be 25. So we're going to have x is equal to 25 minus 4x, or you can write negative 4x plus 25, either way. Now it's just a two-step equation. Let's get the x's all together. I'm going to go ahead and add 4x on the right and on the left side here. If we go ahead and do that, then on the left side, 1x plus 4x is going to equal 5x. So we have 5x equals, and on the right side we have 25. Finally, we can go ahead and divide both sides by 5 here, and if we do that, we're going to see that 25 divided by 5 is 5, so x must equal 5. Alright, so now that we have what x is equal to, let's go ahead and figure out what y is. Now I'm going to go ahead and substitute it into the second equation right away, because if we do that, that one looks, number one, a lot less complicated than the top equation, but second of all, y is already by itself, so when we solve this, we'll have what y is right away. Okay, so I'm going to go ahead and write y is equal to, x is 5 here, so I'm just going to go ahead and substitute in that 5. Don't really need to put parentheses because it's positive here, and then we're going to write minus 2. And then so 5 minus 2, that's going to equal 3. So that one was pretty quick, right? So we found out that when x is 5, y must be equal to 3. Combining these two bits of information, we think our solution here should be 5, 3 over in quadrant 1. Now let's go ahead and just check this to make sure this does make sense. So we have our x and our y value, and this should make the first equation make sense. Let's go ahead and substitute those in. So for the first equation, we're going to have 5 is hopefully equal to 17 minus 4 multiplied by y. Now y, we're saying, is 3. Okay, so hopefully this is true. On the left side, we have 5 is equal to. On the right side, we have 17 minus 12. 4 times 3 is 12, right? And then 17 minus 12 is 5. So since 5 does equal 5, this one does check out. Now it worked for the first equation, so let's just check to see if it works for the second equation. So let's plug this in here. Now y we think is 3, so we're going to say 3 is hopefully equal to 5 minus 2. And this one's a pretty short one, so it's kind of nice. So we're wondering if this is true. Now 5 minus 2 is equal to 3, so 3 should equal 3. And so this makes sense. All right, well, here's one last example. So for number 4, we have the equation 5/10 x plus 6/10 y is equal to 5 7/10. And we have 2x minus y is equal to -1. So a couple quick things that I want to make sure we're aware of that we could probably do to make this easier. Now, in terms of which variable we want to isolate to use for substitution, I think I'm going to use the bottom equation. Again, we really want to look for a term that has a coefficient of 1, so this one having a -1y is not too bad to deal with. So I'm going to take this bottom equation and just rearrange it a little bit. So let's take this 2x minus y is equal to -1. Okay, and if we want to isolate the y, we have two options here. We can move it to the right side, then move the -1 to the left side, or we can move the 2x to the right side and then deal with the coefficient. So let's just go ahead, and I'm going to choose to take away 2x and take away 2x on both sides here. So 2x and 2x, if we go ahead and do that, we're going to get -y, don't forget the negative in front, is equal to -2x minus 1. But we really want y to be completely by itself, so we can go ahead and divide everything by -1 or multiply everything by -1. I'm going to choose to just write divide by -1. And then if we do that, -1 divided by -1 is +1, so we have y is equal to. And then -2 over -1 is positive 2x. And then a -1 over -1 is a positive 1. So notice how we just rearranged the second equation, so now y is completely isolated. We just found out that y is equal to this 2x plus 1, so we can go to this top equation now and substitute this y and change it to this 2x plus 1. However, we do have decimals that are all over this top equation, and to get rid of them, what you can do as a nice little hack here is that you can just multiply everything by 10, since it looks like that's the greatest decimal value that we have here. If you multiply everything by 10, notice what's going to happen here. So we multiply everything by 10, this 0.5 times 10, right? 5/10 multiplied by 10, if we distribute it out, that's going to just equal 5x. Then if we go ahead and distribute this 10 to the 6/10 y, 6/10 times 10, that's just going to be 6y, okay? And then we just go ahead and multiply this 10 by this 5.7, or 5 7/10, that's going to equal 57. Okay, so we just basically made everything 10 times bigger, so this equation over here is equivalent to this equation over here. Everything is just 10 times bigger, but since everything's 10 times bigger, these two equations are the same. Now, if you didn't want to do that and you're totally fine just using decimals throughout the rest of the problem, then just stick with this equation here. But if you prefer not to work with decimals, then just go ahead and use this new version over here to the right. Okay, so let's go ahead and make a substitution now. We're going to say since y is equal to this 2x plus 1, let's go ahead and change this y to that 2x plus 1. So we have 5x plus 6 multiplied by, let's substitute that in as 2x plus 1. And that's going to equal 57. Now we have an equation with just one variable of x, so we can go ahead and solve for it. Let's start by distributing this 6 to both terms inside the parentheses. So we have this 5x, and then 6 times 2x, that's going to equal 12x. And then 6 times 1, that's going to equal 6, and that'll equal 57 on the right side. Combining some like terms here, we have 5x plus 12x, so 5 plus 12 is 17, add their coefficients, so we have 17x plus 6 is equal to 57. Now we just have a two-step equation, so subtracting 6 from both sides here, we can say that 6 minus 6 is 0, so we have 17x is equal to 51, that's 57 minus 6, and then we have to go ahead and divide both sides by 17. If we go ahead and do that, we're going to get 1x, or x is equal to positive 3. So 51 divided by 17 is exactly 3. So we have x is equal to 3. Let's go ahead and figure out what y is equal to. Now again, you could substitute this into the top equation or the bottom equation. I think the bottom one is nicer looking just because we have no decimals. So I'm going to just plug that in right over here. So if we go ahead and do that, we're going to say this is going to be 2 multiplied by 3. Again, that's what we think x is equal to. Then minus y is equal to -1. Now 2 times 3 is 6. We have 6 minus y is equal to -1. And to get y completely isolated, let's go ahead and take away 6 from both sides. If we go ahead and do that, 6 minus 6 is 0 on the left side, so we're going to get -y is equal to -7. That's -1 minus 6. And the opposite of y is equal to the opposite of 7, so if we divide both sides by -1, then we should say that y does equal positive 7. All right, so that's what y is equal to, we think. Now that we know what x and y are equal to, we can say that our solution we think is going to be 3, 7. Okay, so let's go ahead and check that just to make sure. So that would be x, that would be y. And I'm going to check this first by plugging this into the top equation. So let's go ahead and do that first. Plugging into that top equation, that's going to be 0.5 multiplied by x, which we think is going to be 3. And then it's going to be plus 0.6. Again, I'm leaving off the zeros, but you can write them if you want to. That's going to be times 7. And this hopefully is equal to 5.7. Okay, so let's see if that's true. 5 times 0.3, that's going to be 1.5. And then 6 times, or 0.6 times 7, that's going to be 4.2. And then we have that hopefully equal to 5.7. Now, 15 plus 42 is 57. So since 57 is 5.7 is equal to 5.7, then this does make sense. Okay, so feel free to ignore those decimals if you'd like to and then put them back in. But they work out the same way there, so that's kind of nice. And then we can take this solution here as well, and let's just check it in the second equation. This one's kind of nice because there's no decimals. So we have 2 multiplied by 3. We think x is 3. So far, we have no reason to think it's not. subtracting what's y. Y is 7. So go ahead and substitute that 7 in. And hopefully this is equal to -1. Let's go ahead and check this. Now 2 times 3 is 6. So we're going to really have 6 minus 7, and that is -1, I think. Yeah, so -1 does equal -1. So this checks out as well. So there you have 4 different examples of solving systems of linear equations by using substitution. If you'd like to take these equations and graph them, you can do that on an online calculator like Desmos or a graphing calculator just to confirm that these solutions do make sense. You can solve by graphing as well, but you can notice here that since none of these are really in that slope-intercept form, it's a little bit more difficult to graph. So hopefully this new method of substitution saves you some time of not having to use graph paper. And if you can isolate a variable pretty easily, then you can use substitution to solve the system. So hopefully you found this video helpful. If you did, please consider giving the video a thumbs up. And as always, keep up the great work that you're already doing, and I'll see you in the next one.